So now finally, we can start with some modeling. Before we jump into RapidMiner's Auto Model, let me give you a high-level overview. And we're not going through all the details here. I mean, even this overview is not showing them anyway, but let's just focus on some of the boxes you see, like the dashed bordered boxes you see on this on the screen here right now. So obviously the data comes in, and then we start what we call basic preparation. We prepare the target column if there's need for that. We do then remove some of the columns, for example, stable columns, ID-like columns, etc. If you already used automatic cleansing and turbo prep, that is typically not much need for that, but that happens first. So there's a bit of automation going on there. Then we separate the data into training and testing sets, validation sets, and so on. And we move on to the next bigger block, the feature engineering block. So for example, if there's date columns in your data, we extract those dates. If we remember what are the known values in your data. So if later during the application phase, the scoring phase of the model, some new data values are coming along, that the model is not going to be confused and knows how to treat them. We handle missing values if there's still any missing values in this data. Again, if you use auto cleansing from turbo prep, you probably don't need to do this, but for other data sources you may. We handle nominal columns, dummy or one encoding or one-hot encoding. And if there's, for example, text columns in the data, we extract features from those text columns as well. I call this basic feature engineering because that should be a given, not too exciting. But now the really exciting thing for RapidMiner's Auto Model is also this automatic feature engineering, where we use a multi-objective optimization technique, which, by the way, it's close to my own heart because this was one of the major outcomes out of my own PhD thesis. So this is a really, really advanced technique to generate additional features out of the existing one. So after doing the basic feature engineering, we do this full-blown automatic feature engineering. This can be very dangerous because you may introduce something we call overfitting to the feature space. But that is not going to happen with this multi-objective approach because it actually introduces some form of regularization. We will see this a little bit later. Around the automatic feature engineering, we do all the hyperparameter tuning. We first do some pre-tuning, then the automatic feature engineering, then the full-blown hyperparameter optimization, and then the actual model training starts. And here's another thing which is really important. We call this profit-sensitive scoring. This is another novel algorithm which allows you to not just optimize for accuracy or error rates or things like that, but actually try it tells the model how it can best impact the business gains or profits. We do obviously robust model validation, which again is another novel technique how we are doing this. So there's a lot of great things going on there, and you don't need to worry about any of this because for you it's just one single click. And that was actually kind of a lie because it's not one single click, it's 5 clicks, but that's okay. And why is it only 5 clicks? Because that's why we call it augmented machine learning. We try to support you and give you good recommendations as much as needed. And wherever we can, we actually fully automate this potentially still necessary data preprocessing, like the feature engineering we have seen before, or the model selection, hyperparameter tuning, and all of that, generating the results and allowing you to compare the different models. Okay, so now finally, let's go back into the product and let's have a look. So here's the data we had in TurboPrep before. And here I can obviously export it first and load it back into Auto Model, but there is a shortcut here. I can just click on Model, and here is the data in RapidMiner's Auto Model. So it's the same data set. I'm not doing clustering or outlier detection here now, so let's ignore this for now. But what I would like to do is to predict this column here we have generated. All right, predict is pre-selected. All looks good. Moving on. We will come back later to this define costs and benefits button here. But for now, the only change I'm going to do is here to tell RapidMiner that we really would like to focus on the delayed flights first. That's what we want to avoid. And this next step here now is what I would call the heart of RapidMiner's Auto Model. I mean, it's not too exciting at this point because we already did so much work in TurboPrep and we cleaned up so much. But here you see the simple traffic light. A couple of red columns could, for example, mean you should get rid of them. TurboPrep already took care of this. Here's something absolutely mind-blowing. So for example, this column here is highlighted as a yellow one, while everything else is green. So what is this column? Well, it's the arrival delay. Wait a second. That's the one we use to calculate our delay class, the one we want to predict. You remember, if it's bigger than 15, then it's delayed, otherwise it's on time. Well, yeah, I mean, if this is still in the data, all the models will pick up on this and say like, yeah, if it's more than 15, then it's delayed. That's obviously not what we're going to be interested in. And RapidMiner finds this column highly suspicious. Sometimes you're just lucky and it's okay to have a column like that in the data, but in this particular case, certainly not, so we should get rid of this. And just highlighting, giving you this recommendation, that's why we call it augmented analytics, because only you know your business case, only you can make the final call on this, but we at least give you a hint. And the same is true here. So those are the models RapidMiner believes will perform well on your data and will deliver good results in a feasible amount of time. You can override this decision, for example, turn this one on, but that will probably take some time, so maybe let's not do it. And in general, maybe just focus on a couple of the more popular models like those here: logistic regression, deep learning, gradient boosted trees. They're kind of popular. Typically, we do the automatic hyperparameter optimization for you, so you don't need to worry about that. And the same is true for this basic feature engineering. For example, extracting information out of the date columns, like month, quarter of the year. Or if there's multiple date columns, like in our data set, we even build the differences between all of them, because that's often very helpful as well. We'll come back to text later, and also the same is true for the automatic feature engineering, both selection but also feature generation. I'm not going to do this now. Let's just start this run here on this data set. Well, now you can see it's running, and those are the 5 clicks I promised to you. It's really kind of an easy result-based approach. And while we're waiting for the results, we are not going to wait for the full time, but we can have a look into some of the results which are already in. So here's the data set. As you can see, the arrival delay column is gone at this point, but we have a couple of additional columns now, like the extracted information out of the date columns, or those differences between dates I mentioned before. They are here as well. The statistics are here already, but the models will still take some time. Why is that? Because we're actually not just creating one model for each class. We are generating dozens, sometimes hundreds of models for each of the class, and to figure out what is the best model, what is the best network architecture, what's the best number of trees for gradient boosted trees, and so on. So I will stop this run here and just go back to the beginning, because here we actually have a couple of calculated results from a previous run. So I will just load them in here so we can explore those results. Okay, so here we have it. We start with the classification error here on the left, and those models really look very good. Only like between 1% and 2% error rates here. We can see that gradient boosted trees was taking a little bit longer, but in total we generated more than 250 models in less than 8 minutes, because a lot of this is happening in parallel. That's pretty good. And if you would like to see other results like AOC or others, you can just switch it over. The same is true for the ROC curve. But to be really honest, I actually find this almost too good. So what's going on here? So good that we can actually have a look into the model. So for example, for this gradient boosted trees here, let's have a look at this tree, or at this one, or this one. Wait a second, they all are very similar. They all are using this difference between the arrival time and what is this column about? Well, that actually is the scheduled arrival time. Well, what is the difference between the actual arrival time and the scheduled arrival time? Well, that is our flight delays in minutes or seconds or whatever it is. And obviously, that's the same thing as this arrival delay column we based our target on. Okay, so here we made a mistake. We did use a column we shouldn't have been using. We can see the same result also here if you look into the model-specific weights here, which is another novel algorithm coming from RapidMiner, that we can actually build model-specific weights for all the model types, no matter if it's deep learning, gradient boosted trees, logistic regression. It's not just regular global weights like correlation-based weights or anything. It's really model-specific. They're based on the local explanations. I will show this a little bit later. And here again, this difference is too important here. That is just not really great. Well, we'll do this again, this time without this column. But before we do this, let me show you what I mentioned before, multiple models. So for example, here you can see how well the models performed. Red is good, blue is not so good for the different parameter combinations. So you can inspect this here as well. So let's do it right this time. We will, in the second session about augmented machine learning, we will focus on creating like a robust model, which has also a true business impact. So it works like it should work. and we can even prove what this business impact is going to be. And that's really important because it's not just about model accuracy or model error rates or AOC or whatever. It's really about like, what is this model really doing for our organization, and can you show this? So I will introduce this new form of profit-sensitive scoring. That's a new algorithm from RapidMiner. We will obviously correct this little mistake we did before with the arrival time to keep this column in, so we won't do that. And I will also show you some basic text analytics, which you can easily enable here as well. We focus a little bit more on the deep learning model this time as well. So before we go back into the product, let me quickly explain this profit-sensitive scoring to you. I'm not explaining the whole algorithm, but what is it doing? What is it for? So in general, in machine learning, there are techniques where you can define, well, what happens in certain types of errors. So for example, if you predict on time, but it actually is a delayed flight. And especially for two-class problems, there's certainly a dozen or so algorithms around to solve this problem in a more or less efficient way. But the problem is, for more than two classes, it actually is a really hard problem. There are not many algorithms which are doing this, and those which are solving this for more than two classes, they typically build ensembles around your actual model, and that is coming at a price, because now this model itself might already be an ensemble, like for example gradient boosted trees or random forest. Then you build 10 or 20 of those around those ensembles. It makes the model harder to understand. And it also increases training times dramatically. So that is not really acceptable, but sometimes you just have more than two classes, so what can we do? So we came up with a new algorithm, we call it profit-sensitive scoring, which doesn't have those problems. It works for two or more classes without the increase in training time, and it really is a great tool in your tool belt, and you should make use of this. So how are you using this? Well, by looking into the business impact each of the predictions can have. So I'm just quickly going through this. If I, for example, would predict on-time arrival, and it actually is on time, that may have a positive impact on customer loyalty. And I just put the value 10,000 here, a positive number. But if I predict on time and it's actually delayed, then I have two problems. I will lose some customer loyalty, and I actually ordered the gate too early. So that means that I've increased airport costs. And I'm not an expert for that, so I don't really know if that's what's happening. It's just an example. Okay, predicted delayed, but being on time. Well, in that case, I can actually do some airport preparation for a delay, but I offset this with, which costs extra, but that I offset with this with increased loyalty, so that's good. And then if I predict delayed and it is actually delayed, well, at least I don't have an increase in airport costs, but I still will have a loyalty loss. So this is just like an example here, and I will show to you in the product how to use those numbers. Okay, so we're back into Auto Model. So this is still the column we want to predict. Let's go through this. And in addition to focusing on delayed, I can now enter those values here. So 10,000 was for the first one, if I remember correctly. Then we had minus 20,000 here. We had still minus 5,000 here. And minus 10,000 here. So that looks good. All right, so now we have custom settings for the cost, and the rest is all the same. So yes, I get rid of the arrival delay here. And remember, we also need to remove the arrival time. Fine. I always like to look into the textness column here as well. So for example, the highest textness is the origin name. But to be honest, the origin name, like where the name of the airports, I don't think there's much to be learned from. So you know what, I just kick it out even. But the second one here is the weather events. You remember fog, thunderstorm. And while it's not high enough to make the threshold to be automatically detected as text and turn on the text handling at that level already, I can do this here. So let's not change the models this time, but I can do it here by actually forcing RapidMiner to treat this as a text column. So let's do this. All the rest is the same, so we will still extract information from the dates. We will now also extract information from the text. But I'm still not turning on the automatic feature engineering, both selection and generation. That is for a third one. Well, instead of running it now again, I have the results here from a previous run. So I'm just going to load them into RapidMiner, and I'm quickly explaining the results to you in a second. Okay, here we go. First thing we can see is that we have this text information over here. So for example, as a word cloud. So red means on time, blue means delayed. And we can see that normal is a little bit more frequent for on-time flights, while rain, for example, is bigger for delayed, and fog is bigger than for delayed, and even snow is bigger for delayed. So weather potentially really has some impact here. So that's one thing we can see. I mean, there's not lots of different words here, so not much to see here, but still. Then let's have a look here again into the accuracies. Yeah, it looks more realistic. Some of the models no longer performing that well. Some others are doing a pretty good job. Deep learning, in particular, is doing a good job. It's not just getting the best, highest accuracy or lowest classification error, it's also the model which delivers most business impact. So how do we calculate this? Well, that's easy. Let's actually look into this model here, into the details. And here we see what is our best option without using any model. We could make 25 million here. That's by always predicting on time. So we never treat potentially delayed airplanes in a different way. We always treat everything like it would be on time. In that case, that's the best option out of those two here, always delayed or always on time. We make 25 million. But then we can also use whatever the model predicts here. And if we do this, then actually we can turn this into 38 million, and that is the gain of 13.5 million. That's the number we have seen here. So you can clearly see that this model here delivers the biggest business impact. Since deep learning is otherwise pretty much a black box model, so what else can you do with this model here? Well, one thing I like is those prediction tabs here, so where we create the prediction together with the confidence for the different predictions. But then also we can see for each row what is supporting or contradicting the prediction. So for example, here it's the delayed prediction, and in fact was delayed. First of all, it's supported by the origin here. But then also there was some departure delay already that was departing this year as well, and so on. And this is also how we can calculate those model-specific weights we have seen before. So we see in general the delays here is important, but also some weather information like here is really, if there's more bold colors in those columns here, that means overall it's a more important column. So in this next section, I will show you some results which potentially blow your mind. And this is all about automatic feature engineering, what it is doing to your models, and how we manage something we call feature space overfitting. So first of all, the results you will look at in a minute, you will see that we generated more than 175,000 models. We tried more than 46,000 different feature set combinations, and then we also, while we have been doing this, we generated 2,500 new different features, and we did all of this in less than 4 hours, and that led to much better models. But there's often a problem if you do an approach like this, and if you fully automate the feature engineering, which means we are doing feature selection, but we're also generating new columns based on the existing ones. And this problem is that you often run into the problem of feature space overfitting. This was, in fact, the topic of my own PhD or doctoral thesis many years ago. How can you make sure that this problem of feature space overfitting doesn't occur, and we use multi-objective optimization and a special form of regularization to keep this overfitting under control. And if that doesn't mean anything to you, that's totally fine as well. You still will be blown away by the results, because you can actually learn something from this. So I will show you in this section now this automatic feature engineering approach, how to explore those results. You can actually see the trade-off between the model and feature space complexities and the accuracies or error rates. And then we will wrap it all up with another example for how to ensure transparency, that you understand what's going on and can even debug some of those auto model processes here. All right, so let's go into the product. I loaded the results already, so we had a total of 175,000 models and so on. You see this here at the top. And overall, our models look like they're performing a little bit better. Especially the linear models, they really benefited from this feature space transformation and the generation of new features. Deep learning is doing this inherently already as part of its approach. But still, it often can benefit from additional feature generation as well, because it can actually help speeding up the runtime for deep learning. Talking about deep learning, here's another interesting thing is, while deep learning was in fact the one with the lowest error rate here, that's what this little icon means, it was not the model with the best business impact. That was actually this one here. And I always love when that happens, because like we can so easily get hyped and like be excited about the latest new great techniques like deep learning here, while good old linear modeling, especially in combination with the powerful feature engineering, often outperforms other methods, like in this case. No, always, yeah, get some fun out of this. But since deep learning was the best one, let's actually focus our attention on the feature sets for deep learning. So whenever you turn on feature engineering, both feature selection or generation, in this previous screen, in the model type screen we have seen before, you will get this additional result. And what does it mean? So first of all, you get this point up here in the top right corner. That is the original feature space. So it came with like 30 something features here. You see all of them here at the bottom, the extracted text features and everything else as well. But this model wasn't actually that great. It only had like 9–10% of error rate. You could go with a different model, this one here, which has a much lower complexity shown on the y-axis here, only using actually one feature, the NAS delay. But actually, it's not just less complex, it also performs better. It has a lower error rate. Or you can go a little bit higher in complexity, going with all the delays here and really dropping the error rates even significantly down here. And this is a typical curve, this trade-off curve here, where you go up a little bit in complexity until, for example, end up with this one here, which is the one we used, where there's all the delays in here, some information about the weather, and we generate a new one, which is just the product of those two delays. We tried almost 600 other ones for this particular model class here. But RapidMiner figured that there is no value in adding even more complexity. And this is exactly what we call feature bloat, or this overfitting problem, because you could actually drive the error rates further down by increasing the complexity further up here, but not significantly. That's why we went with this point. And this exploration here, that you can actually learn something about the interactions between the feature sets, that's really a fantastic feature of this feature space exploration tool here. Finally, before we actually click on this nice little green button here for deploying some models, I would like to show you that, like for Turbo Prep, also for Auto Model, you can click on this Open Process button, and that will generate the complete process for generating all those models here. You can actually, it's fully annotated. You can go inside here. You can have a look into the pre-processing. You can see every single thing. You could make changes if you want to. But that's, again, it's really about building this necessary trust, giving you the full transparency, making sure that we are not doing any mistakes, and everything is as it should be. All right, this now will open up for this third part of this demonstration here, which is all about deployments and deploying models and managing them.